All right, folks, installment number 100 of Math 2201 MLOs from CDLI. We should have a party for our 100th episode. Nah. Okay, scale diagrams in context. Here we go. We're going to be looking at drawing diagrams to scale. So actually physically getting out there with a pen and drawing a picture, and solving contextual problems that involve scale diagrams. We'll do one of those as well. Okay, so if we have to sketch a scale diagram, it's important for us to have a scale factor. So let's see, whoops, jumped the page on you there. Let's see what we've got here. So if we have a scale factor of 1/2, and all we have to do is apply that scale factor to all of our dimensions here. So let's pick a place to draw our diagram. Let's put the bottom left corner of the image right here. And then we'll draw everything sort of upward and outward from that to give us as much space as we can. So we can see that this dimension had a length of 4 units. So with our scale factor, that's now going to have a length of 2 units. So it's going to take us to there. Okay. And then this dimension had a length of 2 units. So with our scale factor, that'll have a length of 1 unit. Okay. And similarly, this one was 2 units long, so now it'll have a length of 1 unit. This grid paper really helps for this. And then if we have a length of 3 units here, then we're going to have a length of 1.5 when we measure that one out. So that should put us in this vicinity. And then this one had a length of 2. So we're going to have a length of 1 on the scale diagram. And then not much choice, but let's check. We've got 5 units here, so 2.5 looks about right there. So then we just simply play the game of connect the dots, draw them all together. Everybody loves connect the dots. Remember those books you got when you were a little kid to draw those? They were fun. I still do them. No, just kidding. Well, maybe not. Okay, so we connect all those lines and we have our scale diagram using a scale factor of 1/2. Okay, next. In the diagram shown, the house represented in the blueprint measures 56 feet by 98 feet. Okay, so the one that's represented measures that. What is the total cost of the flooring for the bathroom? Oh, it says tiles for the bathroom are 1 foot by 1 foot and are $35.20 for a box of 10. Okay, total cost of flooring the bathroom. So let's see, the longer dimension of the house was 98 feet. We have the scale diagram. Maybe we can figure out the scale factor. So it starts here on the grid at 2, and it goes over to here on the grid, which looks like 51. So if we go from 2 to 51, we've got a distance of 49 grid squares. Okay? So 49 squares long. If the entire thing was 98 feet, then I'm going to say, oh, that's half of it. So we're going to say that our scale factor, and it's strange to write this scale factor with units in it, but in this case, the grid doesn't have units written on it, so we don't know if those are inches or centimeters or what's shaken down here. So we're going to say that it's going to be 1 square equals 2 feet, and that's another way that you can write a scale. So we can say 1 square equals 2 feet because we've got 48 squares to represent 98 feet. So I think that makes sense. So it says the bathroom is what we have to tile. So the bathroom is in here, bath number 1. I don't know why they called it bath number 1. I don't see a bath number 2. So let's see, we got 1, 2, 3, 4, 5, 6, 7, 8 squares long, and 1, 2, 3, 4, 5, 6 squares wide. So the bathroom is 8 squares by 6 squares in the diagram. So on the image we have that, which means on the actual we divide by the scale factor of 1/2 here basically, and that ends up doubling those. So we end up with 16 feet by what do we got? 16 feet by 12 feet, right? That's right. So our bathroom is 16 by 12 feet. And every tile that we use measures 1 foot by 1 foot. Okay, so I'm going to need 16 tiles across and 12 down. If we look at it that way. So we're going to need 16 tiles this way, and we're going to need 12 tiles this way on our bathroom. So our total number of tiles is going to be the product of those. It's like finding an area. So let's see, we've got 16 times 12, which should be 160 plus 32. So 192 tiles is what we're going to need here. Okay, so we got 192 tiles, and it says a box of 10 tiles costs $35.20. Well, they're probably not going to sell us 192 tiles. We're probably going to have to buy in boxes of 10. We're probably going to have to buy 200 tiles, aren't we? So 200 tiles is going to be 20 boxes. We're going to have some left over. Okay, so 20 boxes of tiles is what we're going to need here. And at $32.50, let's see, we got 20 boxes times $32.50 per box. And that's a rate, believe it or not, going all the way back to our earlier part of the unit. So 20 times $32.50 is going to be $630, I think, if I'm not mistaken. So that's how much it's going to cost us. $650, isn't it? Sorry about that. My mental arithmetic is off. Mathematicians are bad at arithmetic. You ever know that? It's funny, isn't it? Okay, so we got $650. Okay, sounds good to me. So let's remember, when we're using a scale factor to sketch a diagram, apply the scale factor only to the distances or linear measures, not to the areas as such, but do the linear ones first. You can figure out stuff with areas later. We'll do some area things with scale factor in a while. So, and remember our scale factor formula, diagram over actual or image over actual. And once the scale factor is determined, required dimensions can then be calculated, and from there we just solve the problem, and we used rates. Wow, going back. Cool. Good luck.